Welcome back. Bill Witte here with more algebra for you. Today we have quite a daunting task, I must say. We're going to cover negative exponents. Now, students tell me that this is one of the 2 or 3 most difficult concepts in algebra. I'm thinking the reason is twofold. One is maybe they missed something in exponents in the first place, and they are in fact exponents. The other is, as you can see, negative exponents look hard. I mean, they got negatives. Nobody ever likes negatives anyway, okay? And the students get nervous, okay? And they look like something probably you've never ever seen before. I should tell you that our basic goal here today is going to turn them into something that you have seen before, okay? So let's get to it. Now, consider that if I talk too fast, as usual, you can always go to my homepage at www.montgomerycollege.edu/algebra. It's important for you to note not to hesitate to go there, because you will be able to replay what we've seen here today, with the exception any of the review parts won't be in that section. If you want to review, you go back to a prior section. And none of my singing will be in there as well, so don't hesitate to go there. Okay? Let's dig in here on negative exponents. Now, negative exponents are in fact exponents. So, whether they're red exponents or purple exponents or Scandinavian exponents, they certainly will still follow the rules of exponents. So it would behoove us to review, and we will review, all the rules of exponents, because the negative exponents are going to have to follow those rules if they want to be in the exponent club. Okay? Well, let's see. What's the deal with exponents? The basic idea of exponents, for instance, that 2 is an exponent, 3 to the 2th times 3 to the 4th, the 3 to the 2th in that position means that we're going to multiply the base, in this case 3, times itself 2 times. And with the 4, as you can see, we're going to multiply the base, which happens to be 3, times itself 4 times. Okay? Interestingly enough, if we multiply those two, I see 6 3's, so you get the idea. Exponents, however many are listed in the multiplication problem, that's what the exponent is. 3 to the 6 can be calculated to 729, but don't worry about that. So, if you look at the 6, and you look at the relationship between the 2 and the 4, it shouldn't surprise you, I hope you remember, the first rule of exponents. And the first rule of exponents is, as long as you have the same base, x to the a times x to the b is x to the a plus b. Like we just saw, 3 to the 2th times 3 to the 4th is 3 to the 2 plus 4, or 6, rather than writing out all those 3's. It's kind of a shortcut. Okay? Another example, you wouldn't want to be writing out 12x's or 5x's for that matter, so we can easily calculate this using our first rule as x to the 17th. Okay? Now, the second rule of exponents is like the first, but it involves parentheses. X to the a, the whole schmicky in parentheses, to the b, is x to the a times b. Now, why would that be? Well, for instance, this, x to the 2th to the 4th, we don't want to write out 4x to the 2ths. Okay, so we have a shortcut. We can multiply and get x to the 8th. Okay, just as a shortcut, save our writing so our hand doesn't hurt so much. Another example, x to the, we wouldn't want to have to write that out 10 times. So using this rule, x to the 5th to the 10th would be x to the 50th. Now this is a rule of exponents, not of regular numbers, only of exponents. There was a tricky part to that. If we look at this next example, numbers or coefficients don't follow that rule. In this example, 5x to the 2nd to the 4th power, while we are going to write out 5x to the 2nd 4 times, will it follow the rule? There's our 4 times. Well, the x part of this is going to follow that second rule. It's x to the 2 times 4, or x to the 8th. But the 5 part of it, we're not going to see a 20 here, because 5 is not an exponent, as you can see. 5 is what we would call a coefficient, or a number, a non-exponent, if you would. So he doesn't follow the rules of exponents. He follows the rules of numbers. And 625 is 5 times 5 times 5 times 5 4 times. Okay? So only use the rules when it's appropriate, and that's only when you're talking about exponents. Thank you. Now we can also have, in addition to positive exponents, we can have 0 as an exponent. Now what would that be? Well, 0 as an exponent has got to follow that rule, or any of the rules. Anybody that's an exponent has to follow these rules. And we know that when we multiply things with the same base, we add the exponent, and 2 plus 0 is 2. So that has to be true. Well, if that has to be true, what in the heck is 5 to the 0th? What would I multiply 5 to the 2th by to get itself 5 to the 2th? Well, this is going to have to be, the only thing that I could put in that place is going to be 1. Think about it. So 5 to the 0th and 1 must be the same thing. And in fact, no matter what you put as the base, x to the 0, anything to the 0 power has got to be 1. So we'll need to remember that. If it's going to follow the rules of exponents, anything to the 0 has got to be 1. Now in this case, the 0, as you can see, only has power over the x, because the order of operations would have me do my exponents before the multiplication, 3 times x. Okay? So that part of it, the x to the 0th part, is going to be anything, in this case x, raised to the 0 power is 1. Okay? The 3 now, we calculate with the 1, and we get a 3. Okay? So just a little bit of a twist there on the 0 exponent. Let's look at, throw parentheses in here with the 0 exponent. Well, now in this case, who does the 0 have power over? We're supposed to do, by the order of operations, what's in parentheses first, the 3 and the x. Well, we can't. So now, basically, what the parentheses do is give 0 power over both of those. Okay? Anything, and in this case, 3 and x raised to the 0 power, has got to be 1. So in this case, the whole schmicky is 1. Totally different answer. Parentheses change things quite a lot there. Okay? Well, let's do a mixture. 2 to the 3rd is 2 times 2 times 2 is 8. 3 to the 2th is 9, 3 times 3. And 4 to the 0th is what? Don't let it catch you off guard. Don't say 0. Anything to the 0, your mother to the 0, is 1. So 8 times 9 times 1, in this case, is going to be 72. A lot of people, give you a lot of examples. Whenever I give you a lot of examples, it's because people have had trouble with it in the past. Okay? I'm not trying to treat you like you're an idiot. Let's take another one. Remember adding polynomials and the idea of like terms. In this example, 5x squared and negative 3x squared, or minus 3x squared, are, quote, like terms. So we'll put those together, and only those together, and get 2x squared. We have any other like terms? Well, the 8x and the 2x, and those together will make 10x. Note that we're not multiplying these, so we're not going to add exponents. We're going to add the coefficients, the numbers in front. A little bit of a difference. And then we have one more set of like terms, the 2 and the minus 5. Adding those together, we get a negative 3. And that's all you can do with a problem like this, is add like terms. Now, we get a little bit more of a twist with subtraction. If we look at the next example, and the idea of subtraction of a polynomial and parentheses. Now this first term, 3x squared minus 8x plus 2, now we're going to want to subtract the whole poopsie, the whole second set of parentheses. So we're going to have to basically change the sign of everybody that's in there. Minus of 3x squared is going to give me a negative 3x squared. But minus of a negative 2x, the negative of a negative, or opposite of an opposite, I'm going to add up with a positive. Now this is what's different than the last problem, is that we're subtracting here. And that plus 5 is going to be a minus 5. Now we're back to, once again, the basic strategy of changing things into things that we already know how to do. we're back to addition, where we just add the coefficients of the like terms. Let's see. 3 and minus 3 is nothing, so I could write 0, but I'm not required to. They just cancel out, kind of a thing. The minus 8x and the plus 2x, well, those I can put together, and I get a minus 6x because I have more negative than I have positive. And the 2 and the negative 5, once again, go together and give me a negative 3. And that'll be your answer. Not so hard. Okay, so that's your addition and your subtraction. What else did we do with exponents? How about distributive multiplication? Let's see, we're going to multiply this 3x squared y to the third times both of those bad boys. I multiply this, these two terms, the 3 times the 5, I get 15. The x to the second times, what is that? X to the what? Whenever you don't have a number, remember that it's a 1 is understood. So we're going to have x to the second times x to the 1, adding exponents. We'll get our x to the third, and the y to the third and the y to the second give us y to the fifth, adding exponents. Okay, now we distribute it to the other one. And remember, when you don't have a coefficient, what do you have? You can throw 1 around like cheap meat. So we have a 1, 3 times 1. And then we'll add the exponents for the x and add the exponents for the y. And we have x to the fourth, y to the fourth. Okay, now we have super distributive. Okay, some of us call it FOIL. In this case, we have to distribute both the 3x and the 5. Let's take care of the 3x times the x, and I get 3x squared. 3x times the minus 7, and I get minus 21x. Now I'm done with the 3x, and let's take care of the 5. 5 times the x, well, let's see. I know I get 5x. Let's put him under what we know he's going to add up to, or add with, as like term. And 5 times the minus 7 gives me the minus 35. Adding like terms, I simply get 3x squared minus 16x minus 35. Okay? Remember all this? I hope so. Let's move to division. Okay? All these rules are going to come into play when we do negative exponents, so we just want to review the regular exponents. Okay? In division, basically what we have here is just rewriting by the basic use of exponents the correct number of variables and canceling. Okay? Now that's a lot of writing. I mean, I could just cancel and cancel. That leaves me x to the third in the bottom, so I have to put it in the bottom. You can see why it ends up in the bottom, because that's where the remnants are. And canceling whatever y's, let's see, what are we going to be left with? Looks like 4 y's in the top. Okay, now that's a lot of writing. There's got to be remember that there was a rule for this, so I didn't have to write all those out and cross them out. And that was our third rule of exponents, that x to the a divided by, just like a fraction is divided by x to the b, is x to the a minus b. So 3 to the 9th divided by 3 to the 4th, I would subtract and get 3 to the 5th. Of course, we can, the opposite of division, we can check it with multiplication. 3 to the 5th times 3 to the 4th would give me the 3 to the 9th. So I know I'm hunky-dinky there. This, without writing all that out, will basically be x to the 12 minus 5, or x to the 7th. Once again, checking, we know we're right, because 7 plus 5 equals the 12. Okay? So if we use the shortcut to redo this problem, we'll have x to the 2nd and x to the 5th. I'll subtract, the easiest subtraction I have, 5 minus 2, and I'll get 3. And I put the answer where the biggest one was, because he's going to win the war. And the y to the 7th and the y to the 3rd, 7 minus 3, is going to give me a 4. And once again, I put the answer where the biggest one was. Okay? The basic rules of exponents. Let's just do one more for review. Okay? Because these exponents are the meat and potatoes of algebra. You need to be able to do these like the back of your hand before we go and do the crazy ones. Okay? Ooh, look at this bad boy. Ugh. Well, let's see. How are we going to approach this? Any problem, how would we approach it? We would do the order of operations first. So we're going to do what's in parentheses first.
Wait a minute.
What's in parentheses? Well, let's see. The 6 and the 9 will cancel. I'm dividing both by 3. I'll get 2/3. Okay, those aren't exponents, so they don't follow the rules. X to the 2th and x to the 6th follow that third rule by subtracting. I'll get an x or 6 minus 2, I'll get an x to the 4th in the bottom where the biggest one was. And with the z's, I'll get a 7 minus 2. I'll get a z to the 5th where the biggest one was. Okay, now I've done what's in parentheses. What's the next thing to do in the order of operations? I've done what's in parentheses, then do whatever exponents are involved that I can do. Well, outside of parentheses, I have this 3. How am I going to do that bad boy? Well, let's take it one at a time. 2 to the 3rd, 2 times 2 times 2 is 8. Z to the 5th, to the 3rd. Now we can use our second rule of exponents and multiply and get z to the 15th. 3 to the 3rd is not going to follow the rules of exponents because he's not an exponent. 3 times 3 times 3, a number, is going to be 27. And x to the 4th to the 3rd is going to follow the rules of exponents. 4 times 3 is x to the 12th. Okay? All right, by George, I think we've got it. Okay? Uh-oh! Now it's time for the new stuff. If you know the rules of exponents, it's time to bring on the bad boy, negative exponents. Remember now, it's going to follow all the rules of positive exponents or zero exponent. We've done that too. Okay, let's see what happens here. Don't leave. Don't go and get a snack or anything or go to the bathroom, okay? Let's see. The number one rule of exponents, and there are no exceptions, is that x to the a times x to the b is x to the a plus b. We remember that. Simply x to the 3rd times x to the 2th, for example, would equal x to the 5th. Well, x to the 7th times x to the 1th, x to the 8th. This is so easy, so easy. You're saying, well, you're doing 72 examples here. Just want to make sure that you want to see the consistency here. Okay, well, what is x to the 5th times x to the minus 2 going to be then? If it follows the rules of exponents. Don't get nervous on me. Follow your rules. We're supposed to add 5 and negative 2, aren't we? Shouldn't surprise you. It's going to be 5 and negative 2, x to the 3rd, and that is the case that, that's going to happen here. Let's see why, though. A lot of people want to ask why. Let's see. X to the 5th times x to the minus 2 is x to the 3rd. What in the heck is the real meaning of x to the minus 2? Well, whatever it is, if you multiply it by x to the 5th, you get x to the 3rd. What's something in our normal language, if you would, that we're used to, that would fulfill that prophecy there? Let's see. Well, let's talk about negatives. Don't back up just a second. The number negative 5, what does that mean? That negative right there, what does that mean in English? It means opposite. Opposite. Okay? And not the kind of opposite that you're used to. Well, above sea level, the opposite of that, below sea level. Above freezing, where else have we seen minus? In the winter, when it's below freezing. Okay? Made money, didn't do it in recent years. That's where you saw a negative. Well, you lost money, the opposite. Okay? But that negative in that position, what kind of an opposite is that? It's important. This is negative 5 plus 8. We use that as an additive opposite. I want you to understand, we use that in addition, or you might say change it to subtraction, but it is an additive opposite. You say, what else is there? Well, I bet you remember there is other stuff. For instance, if we look at the number 5, it has an additive opposite of minus 5, but it also has what I would call a multiplicative opposite. How would I undo 5? If it was in an equation, how would I undo it with multiplication? What would I have to multiply by to get it out of there? 1 over 5. Okay, well, that's kind of an opposite as well, isn't it? Negative 7. What is its additive opposite? Well, its additive opposite is positive 7. What is its multiplication or multiplicative opposite? Well, I'm starting to see a pattern here. 1 over negative 7. I don't think you'd say 1 over negative 7. You'd probably say negative 1/7. It would equal the same thing, wouldn't it? Okay, what about 2/3, these fractions? What is the additive opposite of 2/3? Well, negative 2/3. Basically, to get the additive opposite, you just throw a negative in, or if there's a negative there, take it away. How do you get the multiplicative opposite of 2/3? You know this. It's 3/2. Just switch it over. What about U? What about the additive opposite of negative 4/7? Well, it will be positive 4/7. And the multiplicative opposite of that would be negative 7/4. So basically, the difference between additive opposites and multiplicative opposites are, with the additive opposites, we just change the sign. And with the multiplicative opposite, we just reciprocate. Remember what reciprocate? Whatever's in the top, put it in the bottom. Whatever's in the bottom, put it in the top. Now, what does this have to do with negative exponents? Well, when we have a negative exponent, that negative right there isn't an additive opposite, because an exponent refers to multiplication. It's not an additive opposite. It refers to the multiplicative opposite, or reciprocal. So 5 to the minus 1 power, the multiplicative opposite of 5 shouldn't, or reciprocal, shouldn't surprise you, like 2/3 is to 3/2. 5 to the minus 1 takes 5 over 1, which is what 5 normally is, and reciprocates it to 1 over 5. That's what we mean when we say negative as an exponent. Not an additive opposite. Negative's in a different position. We need a multiplicative opposite. Well, let's take a look. So x to the 5th times x to the minus 2, while it does follow the rules of exponents and give me x to the 3rd, what is this x to the minus 2 going to really be? Well, reciprocating x to the 2th, it's going to be 1 over x to the 2th. Shouldn't surprise you, because x to the 2th is equal to x to the 2th over 1. Does that really follow true? Let's take a look. It must. X to the 5th divided by x to the 2th, does that equal x to the 3rd? Well, let's see. X to the 5th, x to the 2th, of course we could cancel. And hi, Mom, it does equal x to the 3rd, as you can see. So negative exponents do, in fact, mean reciprocate. Okay? That's the deal. X to the minus 2 is the same as 1 over x to the 2th. Now let's see. What would x to the minus a be then? Basically, it means the reciprocal, or 1 over x to the a. Don't start getting nervous on me. We're going to give you about 40,000 examples here. Okay? They're all going to fit right into the rules of exponents. Let's take a look. 6 to the minus 2th power. Okay, well, we know 6 to the 2th power is 6 times 6, or 36. 6 to the minus 2th power means reciprocate that, or 1 over 6 to the 2th. It's not so hard. 1 over 36. 5 to the minus 3rd power. We know that minus, when it's in that position, means reciprocate. 5 to the 3rd power is 5 times 5 times 5, or 125. So 5 to the minus 3rd power is 1 over 5 to the 3rd power, or 1 over 125. Not so hard. Now let's see. Consider this before we go on. 2/3 to the 4th. Now this doesn't have a negative exponent in it, but what would this really mean? That 4 has power over the whole parentheses here. That would mean I'm going to take 2/3 and what? Multiply it by itself how many times? Well, obviously 4 times. Okay? That's what basic exponents mean. Let's see, what would that be, you fraction experts? The top would give me 2 times 2 times 2 times 2 times 2, or 16. And the bottom would give me 3 times 3 times 3 times 3. You can see why we use exponents. We don't want to say all that. It would be 81. Okay, now that's just a normal fraction with an exponent. How is that going to change if I take that problem and throw in a negative exponent? Don't get nervous on me. What does the negative mean in that position? It simply means the multiplicative opposite of whoever it has power over. Okay, now who does that negative have power over? The whole poopsie. Okay, the whole thing that's in parentheses. So if we take that, that says take 2/3 and make it 3/2. Now what does the 4 tell me to do? Okay, the negative told me to reciprocate. The 4 tells me, like you just told me before, to multiply that by itself 4 times. You knew that already. Okay, so this is just basic multiplication except for the reciprocal with the negative. The 3's will give you 81 and the 2's will give you 16. So that's not so hard if you think about the idea of multiplicative opposite. Uh-oh. Now in this case, the negatives don't have, like for instance, the negative 3 only has power over the 2, and the negative 2 only has power over the 7. So you only reciprocate what it has power over. Well, let's see. If we reciprocate them, they become positive. And we love positive. We know all the rules of positive. So let's see. I'm going to take that 2 to the minus 3 and send him downstairs. And take the 7 to the minus 2 and put him upstairs. And I'll end up with now some positive exponents. I know what they do. 7 to the 2th is 49 and 2 to the 3rd is 8. It's not so hard. So basically, my strategy is I hate negative exponents. So take them and turn them into positive exponents. How do you do that? Reciprocate. Let's look at this bad boy. Now some are negative and some are positive. Okay, let's take things one at a time. This guy is negative and he's up in the top, so let's put him down in the bottom. Okay, we took care of him. This guy's positive. Leave him alone. He goes right, oh, we're only going to reciprocate the negative ones. He's a positive one, so leave him alone. Okay? Okay, who else we got? Z to the minus 1 up top, go downstairs. Okay, that's the whole top. X to the 5th down in the bottom, well, since he's positive, he's going to stay in the bottom. Okay? Y to the minus 2 in the bottom, since he's in the bottom, when you reciprocate something in the bottom, where does it go? Doesn't have much other place to go. To the top. He's going to go upstairs. Go upstairs! And Z to the minus 2, once again a negative in the bottom, will reciprocate. He'll go upstairs. Okay? And now, it'll just follow the normal rules of exponents. Things that are together, when we want to multiply them, we add exponents. So you see why you needed to know the rules of exponents? Now these guys are on the same side, but they're in the bottom. So we'll add exponents again. Okay? 3 plus 5 is 8. Now these, the z's, are going to cancel, and you'll use the third rule of exponents, subtracting. Put the answer where the largest one was. And look at that. That's not so bad. Basic strategy, change your negative exponents into positive exponents by reciprocating. What about this one? A little bit of a twist here. Let's take that guy, he's negative, and put him downstairs because he was in the top. Let's take him and put him downstairs. Okay. Now, x to the 6th is going to stay right where he is because he's a positive exponent, right? We only reciprocate the negative ones. This seems like the same problem. What's so hard about this? The z to the minus 2 is going to go upstairs. The only possible difference, and this is kind of a review, should be, because it's just following all the rules of regular exponents, is that these two guys are going to get together and become x to the 8th. These two guys are going to cancel, 7 minus 2, and give you a z to the 5th where? Where the biggest one was, in the bottom. But now I don't have a top. You need a top. What do we put? What can we throw on like cheap meat?
Wait a minute.
Well, you have to have a top. So who's coming in? There's your boy. Okay? Remember 1, your old buddy. Okay. That wasn't so hard. Now, it's not going to get any harder than this one. Okay, let's see. Oof. Now, let's see. We know that we have to
Wait a minute.
do what's in parentheses first. Same rules. Follow the order of operations. So let's do what's in parentheses first. Let's see. The 2, nothing happening to him. He's staying right up top. X to the minus 2 is going to go in the bottom. Z to the minus 7 was in the top, so he's going to go in the bottom and become positive. X to the 6, you stay right where you are, Buford. Z to the minus 2 is in the bottom, so to reciprocate him with our negative exponent, he'll go in the top. Well, now to complete what's in parentheses, don't even look at that minus 3 yet. To complete what's in parentheses, let's see what we have to do. The 2, nothing's going to happen there. The x's, we'll multiply those and get x to the 8th. And the z's will get canceling, and we'll get z to the 5th by subtracting. Now, and only now, we'll work on our buddy negative 3, because we've done what's in parentheses first. Well, let's see. 2 to the minus 3, that minus 3 has power over everybody. Okay? Now, I've taken care of the 2. What about the x to the 8th? What do my rules of exponents tell me to do with that x to the 8th and an exponent outside parentheses? The second rule of exponents tells you to multiply. What is 8 times minus 3? Negative 24. So don't get nervous on me. Just follow the normal rules. 8 times minus 3 is negative 24. Now, we'll do a little bit more with it later, but all things in good time. Okay, what about the z? Follow the rules of exponents. Z to the 5th to the minus 3rd. Multiplying 5 times minus 3, we get z to the minus 15. Now, nobody likes negative exponents in their answers, so let's do reciprocals where appropriate. The 2 to the minus 3 is going to go in the bottom and become a positive exponent. The x to the minus 24th, while it's in the bottom as a negative exponent, we'll put it in the top, and we'll have a nice, sweet, positive exponent. And the z to the minus 15th in the bottom will go in the top. Not so bad. Is there anything else we can do here? Well, I'm thinking we can do something with that 2 to the 3rd and actually complete it. And that is one that you want to put on the refrigerator door for Mom, because that is about as hard as it's going to get. And that wasn't so bad if you just remember, what do negative exponents mean? They mean to reciprocate, the multiplicative opposite. Okay? Now, we think we know everything about negative exponents. Why? Why am I bothering you with negative exponents? Are they useful? What are they good for? What are we going to use these for? You're going to use them. Okay? Before I tell you, consider this. See if you've ever seen anything like this before. X to the 2th, of course, is 10 times 10, or 100. Or, I'm sorry, 10 to the 3rd is 10 times 10 times 10, right? You know this. Or 1,000. 10 to the 8th, now we're starting to get into some big numbers, is 100 million, okay? A bazillion, no, 100 million. Now what about looking at multiples of 10 and negative exponents? Okay, 10 to the minus 2 is 1 over 10 to the 2th, isn't it? Or 1 over 100, known downtown in Decimalville as 1/100th. Decimals come into play here. What about 10 to the minus 3? Would mean 1 over 10 to the 3rd. Or 1 over 1,000, known downtown in Decimal Town as 1/1000th. 10 to the minus 8th, just to keep in consistency here, would be 1 over 10 to the 8th. Oh, what's that going to look like? It's going to be a very teeny number, whatever it is. I think it's 1/100 millionth or something. Now, when would you have such a small number, okay, or such a large number for that matter? Why do we need negative exponents? Well, in science, we have very large and small numbers. The speed of light, for instance, is a large number. 186,000, that's a big number. And we get way bigger than that. You know what the distance to another galaxy is? You would be spending a lot of time writing zeros, okay? And that's not, you know, it can get much larger than that. That's very large numbers. What about some very small numbers in science? The weight of an electron, that's teeny weeny is, I don't know, that's a very small number, a lot of zeros, okay? I smell negative exponents. Of course, the percent of students that like negative exponents, and they're again a very, very small number if you get my drift here. But once again, we don't want to get caught up writing a whole lot of zeros. So we're going to use negative exponents to write things in science. Hence the term scientific notation. The way to write things, rather than sit there and write 3,000 zeros, okay, we're going to do what scientific, now what is scientific notation anyway? Okay, the definition of scientific notation is, a times 10 to the nth. We're going to take a large or small number and put it in the form where a is some number between 1 and 10, and n is some integer, positive or negative, or 0 for that matter. Okay? A times 10 to the nth. Let's take a look. 3.1 times 10 to the 6th is already in scientific notation because it's some number between 1 and 10, 3.1, times 10 to the 6th, 10 to some integer. In this case, that integer is 6. But we'll always have 10 in here. Okay? And basically, 3.1 times 10 to the 6th is 3,100,000. It's a very large number. But we can shorten it by writing it in scientific notation. Note, we picked a number between 1 and 10, 3.1, and we moved over, in this case, 6 places to get to back where we were, and that's where we got the 6. Now, however many digits you have to move over. Okay, now how did you know whether it was a positive 6 or a negative 6? This is going to be important. I don't want you to remember, oh, I moved to the left, and it's or I moved to the right, because it really doesn't matter. The easiest way, because you may forget, you may mix that up. I think the easiest way to remember is, if it's a large number, shouldn't surprise you, it's going to be a positive exponent. And if it's a very small number, teeny weeny weeny, then it's going to be a negative exponent. Okay, let's do a whole bunch of examples for this if we can. 3.1 times 10 to the 13th. Ugh, how did I come up with that? Okay, I'd much rather write it in scientific notation, as you can see in blue, rather than all those zeros. I picked a number between 1 and 10. I had to put the decimal somewhere. Right now it's at the end of the number. But I put the decimal here, giving me 3.1. And then I counted over how many places I had to go to get it where it should be. And if you count that, I promise you, it's 13. Now how did I remember not to go the other way? How come I didn't go 3.1 and go backwards to the left? Because I remembered, I'm not going to remember my left and my right, okay? I'm going to remember that a very large number, and I should have gotten an answer here that's very large, and I did, because I had a positive exponent, 10 to the 13th, okay? Now here's a very small number. This one has a negative exponent, so it better end up being very small. And in son of a gun, that's the correct number. That is a teeny number. Now, how could I have come up with that? I took 7.9, the number between 1 and 10, that's where it originally was, and I moved in whatever direction it takes to make it small. In this case, it's left. And I moved back over 12 places. Now, you can count them, but there are 12 places, and that's where I put the decimal place. Okay, see where it went? Now why isn't it, whatever that is, 7 gagillion or whatever, why didn't I, because that's a very large number. So I didn't want to go 12 places to make it a large number because I had a negative exponent here. I wanted to go whatever direction it takes to make it a small number. Okay, so while positive exponents yield very large numbers, negative exponents, shouldn't surprise you, are going to yield small numbers. So a whole bunch of these because you are going to use these, okay? 3.1 times 10 to the minus 4th. Now I don't have any 0 places to put for 3.1, so I'm going to create them. I put my decimal at the 3.1 and I move over 4 places in the smaller direction, if you would, okay? Negative exponents yield small numbers. Remember that. Okay, let's go the other way. For the speed of light, for instance, how am I going to write that, and this is the more useful, if you would, how am I going to write that in scientific notation? Well, number between 1 and 10. So I have to put the decimal at a place. In this case, I put it between the 1 and the 8, 1.86. A has got to be between 1 and 10, and n, the number with the 10, has got to be an integer. So I put it at 1.86, and then I actually physically counted how many places it took to get over there, and it was 5. And that's where I got 1.86 times 10 to the 5th. That's the speed of light written in scientific notation. Let's do a couple more. Why not write it as, just in case you're confused, why not write the speed of light as 18.6 times 10 to the 4th. That's kind of like in scientific notation. Oh, no, it's not. Because when you put the decimal right there, and son of a gun, it works. That is 4 places. But that does not have A being a number between 1 and 10. 18 is not between 1 and 10. So you're going to have to put it, and there's only going to be one place. That way we'll all be writing our scientific numbers the exact same way. You might call that a convention. We're all going to write things the same way. So remember, that number has to be between 1 and 10. Okay, let's take a look at another example. The distance to another galaxy. Now this really asked for scientific notation. We're going to need a number between 1 and 10. The only place you could put it where you'd have that would be between the 1 and the 2, or 1.2. A, in son of a gun, that 1.2 is between 1 and 10, and n, in this case 15, is an integer. Shouldn't surprise you that it's a positive exponent because it was a very large number. We started at 1.2, counted over however many places that is. I promise it's 15, and that's where we got the 10 to the 15th. My Aunt Bertha's weight. She's a big one. What would that be? 4.3 times 10 to the 10th? Because we needed to put that decimal where the number was between 1 and 10. You can't just put it anywhere. And then you could use the appropriate number of digits for the power of 10. In this case, we put it between the 4 and the 3 to make it between 1 and 10. And we counted over however many places it took to get back to its original spot. And son of a gun, that was 10. So the appropriate answer, writing that number in scientific notation, and we will ask you to do that on a test, is 4.3 times 10 to the 10th. Note, my Aunt Bertha, if you saw her, you would understand that this is a very large number. So you shouldn't be surprised that it is positive exponents. The weight of an electron, a teeny, meeny little electron, is this number. You'll be here all day writing zeros. So the shortcut is going to be 2.3 times 10 to the minus 14th. Where in dog lips did I get that? Well, I knew I needed a number between 1 and 10, and I knew I needed an integer. Remember that negative numbers are integers. In this case, negative 14 is an integer. So I put the decimal, that's where it started off. I put the decimal between the 2 and the 3 to create a number between 1 and 10. And then I counted the space in between. Now, I don't care whether you counted left to right or right to left. You counted 14 spaces, and you knew that this was going to be a very small number. So that's where the negative 14, the 14 came from counting. The negative came because it was very small. Okay? Couple more. How long does it take to get a LASIK operation? You ever get an eye operation? I got one, and I was a little nervous that they were going to come in and cut me or whatever. But actually, this thing, this light, got on my eye and just went, beep, and it was over. Of course, then they had to move over to the other one. Beep. Okay, it took a tick's navel of a second to do that operation. And as a matter of fact, they told me it took this number of seconds. Okay, how would I write that number in scientific notation? Well, let's see, I had to, now this is a little bit different because it has a couple decimal places. I had to put the decimal, I know it's a small number, I had to put the decimal place between two numbers so I would get a number between 1 and 10, right? So I put it here. Okay, then I counted the number between where it originally started and where it ended up to get it between 1 and 10, and there was 5. So that's where I got my 10 to the minus 5 because it's a very small number. So your scientific notation for the LASIK operation would be 2.23 times 10 to the minus 5. Very useful stuff, this negative exponents. Okay? One more. Just one more. Because this is, to me, I'll tell you what, if you've got this, you should smile. Because this is not easy stuff. Okay? And if you understand negative exponents, you understand all the exponents. What would 3.1 times 10 to the minus 4th? Now, it's already in scientific notation. They want me to write it and turn it around and write it as a, I guess in this case, a very small decimal number. Well, there it is. I'm going to take between the 3 and the 1 and move over 4 places. And that's how I got it. Shouldn't surprise you once again that it is a very small number. Okay, what do we need to remember about negative exponents? Negative exponents, x to the negative a, just means reciprocate, or 1 over x to the a. That's what the negative means, the multiplicative opposite. 6 to the minus 2 means 1 over 6 to the 2th, or 1 over 36. What about a fractional negative exponent? Well, let's see. This part of it means reciprocate it, and the 4, of course, basic exponent rules means multiply it by itself 4 times. And in this case, I'll get the 3's multiplying, you may remember, to 81, and the 2's multiplying to 16, and bam, we got ourselves an answer. Okay, now what about when we're dealing with variables here? No one likes negative exponents, so we're going to change them into positive exponents. Remember the trick there? Only the guys that are negative I'm going to reciprocate. So x to the minus 3 while he's upstairs is going to go downstairs. Y to the 1, oh, don't reciprocate him. He's not negative. So just leave him right where he is. Z to the minus 1, Z to the minus 1th, let's reciprocate him, put him downstairs. Now he's positive. Okay? X to the 5th, stay right where you are, Buford. You're already positive. We'll reciprocate y to the minus 2, put him upstairs. And z to the minus 2, put him upstairs. Now we'll just complete the problem using my normal rules of exponents. Let's see. The y's will get together using the first rule of exponents, adding exponents. The x's will get together in the same fashion, adding exponents. Now the z's, I'm kind of dividing there, so I'm going to subtract, put the answer where the biggest one was, z to the 2th, z to the 1th, gives me a z to the 1th, or z. Remember that? Remember this bad boy? We were supposed to do what's in parentheses first, of course. Let's see, same thing, just do what's in parentheses. 2's not going anywhere. X to the minus 2 will go in the bottom. Z to the minus 7, go downstairs. X to the 6 will stay right there. And z to the minus 2 will have to go upstairs because he's a negative exponent. We reciprocate. Okay, now we'll complete what's in parentheses first using the order of operations, the basis of all algebra. Let's see. 2, you'll stay right there. X's you'll get together. X to the 2th, x to the 6th, x to the 8th. And z's, once again, they'll cancel and put the answer where the biggest one was. Okay. Now, we'll do this minus 3 part. 2 to the minus 3. X to the 8th to the minus 3 follows the second rule of exponents, multiplying exponents. And z to the 5th to the minus 3, once again, follow the rules of exponents. The second rule says multiply exponents outside parentheses. Now let's see if we can get rid of these negatives. We got rid of some already. Take the 2, he was in the top, put him in the bottom. Take the x to the minus 24th, put him in the top. Wow, we're cleaning up big time. And the z to the minus 15, put him in the top. We're cleaning up big time. Anything else we can do you may remember? 2 to the 3rd, I can actually complete and get an 8. They won't get that hard. They won't get any close to that hard. Okay? Remember the definition of scientific notation. Taking a very small or very large number, multiplying it, changing it into the form a times 10 to the nth, where a is a number between 1 and 10, and n is some integer, whether it be positive or negative, or it could even be 0. Okay? For instance, 3.1 times 10 to the 13th is in scientific notation. Another way to write that, though inefficient, would be 31, what is this, gagillion or something, okay? I found that the decimal spot for a number between 1 and 10, 3.1, counted over however many places it took to get back to its normal spot, and that was 13. Scientific notation with negative numbers, with negative exponents, are for very small numbers. this number is going to be a very small decimal. I find the position that gives me a number between 1 and 10, in this case 7.9, and count over to the original position, in this case 12 places, so I know I'm going to have a negative 12 because it's a very small number. So while positive exponents yield very large numbers, negative exponents are going to yield the small numbers. Let's go back the other way. Our speed of light is going to be a number between 1 and 10, 1.86 times 10 to the 5th. How did I get that? I located the decimal where I would have a number between 1 and 10, and then I counted over the appropriate number of places to get it back to its original spot. Noticing that this was a positive or large number, I used a positive exponent. So my answer in scientific notation, 1.86 times 10 to the 5th. Hey, wait a minute. Okay, very small number. I'm going to end up writing it as a number between 1 and 10 times 10 to the minus 14th in this case. I locate where it would be between 1 and 10, in this case 2.3, count the number of places, and I can see where that minus 14 came from. The 14 came from counting the places, the minus, because it's a very small number, I think. Okay, well now it's time for you to practice and for me to get out of here. Till next time, and if you have trouble, don't be afraid to go to the home page, www.montgomerycollege.edu/algebra. We'll see you next time, and practice those negative exponents. Do your homework.